First of all, let me introduce myself. My name is John Renton. I'm professor of geology at West Virginia University, and I'm here to teach you something about Earth. Now, it's customary to start a course off like this by giving some statement as to what my intent is. Most teachers do that. And let me tell you what my intent is not. My intent is not to turn you into a geologist, because I'm sure you have a profession of your own. But about several weeks ago, I received an email from one of my former students that I think spells out beautifully just what my intent really is. This student was in my class 30 years ago, now lives in California, as you'll see in a moment. And here was his email. We had a shake here a few minutes ago, a jolt that rocked the house and told me the epicenter must have been close by. Checking the USGS website indicated it was just off the Golden Gate, 8 miles down. But this time I was on my computer, and I thought I'd Google you up and tell you how fortunate I feel for having taken your classes in geology in 1973 when I was a freshman at WVU. Though I never became a geologist, I often draw upon what you lectured about when I'm cruising around California, which has some of the most dramatic terrain in the world. I can explain to my daughter why this beach has sand and that beach has rocks, or how it is that rivers' courses are the way they are. Well, she thinks I'm pretty bright. But in fact, I'm just passing on what I got from physical geology. To finish, I'd just like to say that hardly a week passes that something doesn't cause me to think about your classes. And so I think that really spells it out. What I'd like you to get out of this course is information that you will take with you for the rest of your life, wherever you go in the world. I don't care whether it's a trip to the office or on vacation, so that you can look at the world that passes you by in a little bit different fashion, understanding it better, appreciating it better. So if you do that, then my intent will be fulfilled. Now, the other thing I'd like to do is to give you some idea of what the overall course is going to be like here. And I divided this course into 12 topics. The first topic is going to be called Earth and its place in space, because I think it's very important for students, for anybody getting into a course in geology, to have an idea of where you fit into the big picture. And of course, the big picture is going to be the universe. So we'll do that first, and then we'll go into the two sections on rocks and minerals. You have to understand what the Earth is made of, and so we'll talk about minerals first. And there are thousands of these things, but you're going to find out there's only a handful, a couple of dozen, that make up almost all the rocks of the world. So it isn't really very taunting there. The next one's going to be the rocks themselves. There are three basic kinds of rocks: igneous rocks, metamorphic rocks, and sedimentary rocks, and we'll go through each one of those and explain how they form and where they come from. And then we'll go into one that students often like to talk about, volcanism. This is probably one of the most spectacular features that are happening on the Earth today. Not so much in the East, of course. We don't have it in the East, but in the West, there's lots of volcanism going on. Those of you who might have traveled to the northwest of the Cascades, we'll talk about that. And then after that, we're going to go into a series of lectures, the ultimate goal of which is to describe how the land has come to look like it does. Surely in all your travels, you know that land changes its appearance. You don't have to go very far because the topography looks different. Well, for the next few topics, we're going to talk about things like mass wasting. Mass wasting, I always say, is the unsung hero of all geologic processes, because it goes on without most people knowing it's even going on. And then we'll go into perhaps one of the most important of all the geologic processes that are happening out there. It's called weathering. Weathering is the process whereby rocks either decompose or disintegrate into bits and pieces to be carried off, dumped into the ocean, and created into a new rock, usually into a sedimentary rock, but we'll get to that. And a part of this topic, we're going to talk about soils. Now, the reason why is because soils are made from the products of weathering. And the reason why I want to take it up in this course is because without soils, you and I wouldn't be here, and you'll see why when we get to it. Then finally, we'll talk about the sculpting of the land. The processes that do the sculpting we call erosion. Streams are the number one. Anywhere you go, anywhere that water can exist, streams are the number one agent of erosion. So when you go out there and you look at the land, most of what you're looking at is the result of the combination of mass wasting and streams having done their thing. But there's also glaciers where they exist. They're very, very good. It just obviously they don't exist very many places except where it's cold. And then we'll finally go into the wind. The wind is sort of number three, but it's a distant number three. It's given credit for doing an awful lot of things it really doesn't do, and we'll talk about that. And then the next topic I take up, I'm going to talk about groundwater. Now, I had to pick and choose as to what we were going to cover in the course. I picked groundwater because this water now provides half of all the drinking water in the United States. And it's going to become more and more important as years go on. And we've got to remember that it's a non-renewable resource, and we've got to protect it and use it wisely, something we've not been known for in the past. But anyway, I want to talk about groundwater so you have a real feeling for what that's all about. And then I'm going to go into the last three topics are going to be rock deformation, earthquakes, and mountains. They all sort of go together. Rock deformation is just what it says it is, breaking and bending of rocks. Earthquakes are the result of some of the breaking of rocks, as we'll find out. And then we're going to complete the course with a discussion of mountains. And the reason why I have this at the end, in my way of thinking at least, mountains are sort of the last remaining thing of all the totality of all we're going to talk about. It's the epitome of what geology is all about. It's all the processes we'll have talked about working together and making what has to be the most spectacular thing on the Earth's surface. So anyway, that's what the course is going to be about. And where to start? I've often thought that the place to start a course in geology is in the beginning. And in the beginning, the astronomers tell us there was no need for geology because there were no rocks, there were no minerals, there was no Earth, there were no stars. They tell us there was nothing. So my question would be, what about all this stuff out there in the universe? Where was it? Well, that depends upon to whom you speak. There was a Belgian astronomer named Lemaitre who said that all the stuff we now see in the universe, not all of it, was once crunched down, possibly into a sphere about the size of a golf ball. Now, obviously, whatever was in there wasn't matter as we know it. The conditions would have had to exist in there would not allow matter to exist. It would have been ripped apart. Even the stuff matter is made would have been ripped apart. Atoms and things like that. Question, what was in there? Well, they say that what was in there were things called quarks. And what a quark is, according to a physicist, that's the smallest subdivision of matter. So in his case, he called that the primeval atom. His primeval atom was filled with quarks. Now, if that's not a good enough theory for you, here's another one. The crunch could even go further down to what is referred to as a singularity. A singularity, by definition, is a non-dimensional spot. What's there? Nothing but energy, just pure energy. And then what happened? Well, according to the theories, what happened then was an event that we usually refer to as the Big Bang. The Big Bang, what was it? Well, it again depends upon whether you believe